Today we are going to go over lesson 9.2, prime factorization. And in this you will see a lot of similarities between prime factorization and the rules we use to simplify numbers, okay? So our factors are whole numbers that are multiplied to find a product. So for instance, in the problem, 4 times 2 is 8. 4 and 2 are my factors. 8 is my product. So they give us an example here. Let's see what this is. Anna wants to build a rectangular garden with an area of 24 square feet. What is the possible whole numbers and widths of her garden? Hold on, I want to get a rectangle to help you visualize. So there we go. So you might remember, you might not, that your length times your width equals area. So basically two numbers, in this case, that multiply to 24 because she wants an area of 24. So she could do 1 foot wide, 24 foot long. Okay. She could do 2 feet long and 12 feet wide. There's another example. She could do 3 feet long and 8 feet wide. Or she could do 4 feet long by 6 feet wide. So she has lots of choices because each of those two numbers will multiply to get to 24. And there's a chart of her choices. So list all the factors. So if I wanted to do 21, I can multiply 1 by 21. I could also multiply 3 by 7. Either of those would work, which means my factors of 21 are 1, 3, 7, and 21. Now, if I wanted to get the factors of 37, 37 is a prime number. So the only two things I can multiply together are 1 and 37, which means the factors of 37 are 1 and 37. So let's look at our options for 42. We could multiply 1 times 42. We could do 6 times 7. We could do 2. So we could do 2 times 21. And we could multiply by 3. 3 times something. So if you're not sure what it is, let's go over to the side here. 42 divided by 3. 3 goes into 4 one time. Bring down the 2. And we can use 14. And by the way, let's talk about how I knew that 3 would even work for a second. So I said you can use the same rules as you use for simplifying, meaning 42 is even. That means it will be divisible by 2. 4 plus 2 add up to 6, and 6 is divisible by 3. So it will be divisible by 3. So I have factors here of 1, 2, 3, 6, 7, 14, 21, and 42. So using those rules that I said I would use, I know that 30, well, so we could do 1 times 30, right? I also know that 30 is even, so it's divisible by 2. That means 2 times something is 30. 2 times 15. 3 and 0 are both divisible by, 3 plus 0 is 3. So 3 is divides into 30. That means also 3 times 10 is 30. 5. So if the number ends in 0 or 5, it's divisible by 5, which means 5 times 6 is 30. So you can see I can start to use those same rules that I've been telling you repeatedly to try when you're simplifying numbers or finding factors. Use 2, use 3, use 5. And ultimately, we want to be able to do this because we want to be able to find the prime factorization. The prime factorization of a number is the numbers written as a product of the prime factors. So it's all of the numbers in kind of, you can think of like their simplest form that are prime. And as we go through, this will make some sense. So list all the factor pairs of 240. And they first said that one of the factors is something times 48. I got to tell you, this is not the way I would start it. Later on, they're going to ask us to do it a different way. So 48. So I'm going to have to do a bunch of guessing and checking. So let's erase this. And I'm going to guess 5. It's actually what I'm going to guess. I think that's right. But I'm going to have to do guess and check here to check. 0 times 5 is 0. 5 times 4 is 20. 5 times 2 is 10 plus 2 more. 5 is 10, 11, 12. That's the problem. I'm dividing, multiplying by 5. I need to divide by 5 because I'm guessing and checking backwards. 240. So maybe you guys caught what I was doing wrong, and I leave these mistakes in my videos, and I don't worry about them when I'm making them in class because I want you to see that sometimes we get sidetracked and we start doing one thing and we're thinking about others and we make a mistake. So we need to go back. So 5 goes into 24 4 times. 4 times 5 is 20. 24 minus 20 is 4. Bring down the 0. 48. So 48 times 5. So they did one of the things I said is to check for 3, 2, 3, or 5. I just would have done 2 first. Or I might have done 24 times 10. I might have seen that one really easy. So 5 is a prime factor. I cannot get, there's no numbers that multiply to get 5 except 1 and 5. So a prime number is any number that the only factors are itself and 1. So let's look at 48. So I'm going to say that I know that 48 is 6 times 8. And those aren't prime factors. Those aren't prime. 6 factors of 6 are 2 and 3. Now those are prime numbers because the only number that 2 is divisible by is 2, which is itself, and 1, and the same thing for 3. And then I'm going to go back over here and I'm going to say my factors of 8 are 2 and 4. And so you'll see I'm circling each one when I say, okay, this is, I can't go any further. I can't factor down 2 any further, but 4 I can. And I'm going to get 2 times 2. Now, in the problem here, I should have circled those in purple. It said, let's the factor pair. So I could have started with other numbers between 5 and 48. I started with 5 and 48 because this drawing here had the 48. Now it says, choose any factor pair to begin the tree. If a number in this pair is prime, circle it. So that's what I did. 5 is prime. If it can be written as a product of 2 factors, draw additional branches. So that's what I did. 48 is divisible, is 2 numbers that multiply to get 48. 2 factors of 48 are 6 and 8. Neither of those are prime. So for the 6, I drew 2 branches. I got 2 and I 3. And so then they want you to write the prime factorization. So there's a lot of ways you can write this. I'm going to write it the order that I found it. I got a 5 times, and then I found a 2, and then I found a 3, and then I found a 2, and a 2, and a 2. So this is my first 5, then my 2, 3, 2, 2, 2. Then write the prime factorization using exponents. So when you're doing this, you want to start with your smallest base first. So I have 2 to the, let's count how many 2's I have. 1, 2, 3, 4. So I have 2 to the 4th power. I only had 1 3, and I only had 1 5. So now they say, what if I'd started the tree differently? Let's see what would have happened. So you could have done anything. I'm going to do 10 and 24. Neither of those are prime numbers. But 10, two numbers that multiply to 10 are 5, and 2, remember, you don't want to use 1. And both 2 and 5 are prime numbers. So over here, sorry, this shouldn't have been, you guys might have caught that. It's not 240, it's 24. It's like, wait a second, I just did 240. So two numbers that multiply to get 24 are 3 and 8. 3 is a prime number, so I'm going to circle that. Two numbers that multiply to get to 8 are 4 and 2. 2 is a prime number. 4 is not. And let's see if that's the same thing. So let's see here. I'm going to use my red, purple. So let's see how many 2's I got. I got 1, 2, 3, 4. So I got 2. I got 4 of those 2's. That's what 2 to the 4th means. Times. I got 1 3 as a factor. And I got 1 5. I want to be able to do this for a few reasons. I need to practice how to factor and break things down. And this is the beginning of, as we move into, for the next few years even, our ability to do algebra. We're eventually going to have to do this with letters and with terms, and we need to be able to understand this concept of factors and factorization. So this is how you do a factor tree. You can also use a ladder diagram. And the trick with the ladder diagram is you want to specifically divide by prime numbers. And this is why I tell people all the time, tell students, start with 2, use 3, and use 5. Okay? So if I look at how they started this, 132 divided by 2, and they got to 66. So I'm going to treat this like I would tell you to simplify fractions. And since 66 is even, I'm going to divide by 2 again. And I am going to get 33. And from 33, I can divide out and get 3. And 33 divided by 3. So I can pull out another, wait, hold on. So 2 divided by 2 is 66. And 66 divided by 2 is 33. And 33 divided by 3 is 11. So my factors of this should be 2 squared, because there's 2 squares, a 3, and an 11. Okay? And if I wanted to do it like we did the tree diagram, I could see if I started with 132, I got 2 and 66. What if I did this differently? What if from 66 I did 6 and 11? I could have done that. 11 is a prime number. 2 and 3. So I still got 2 squared times 3 times 11. I just want to make sure that if you see a ladder diagram, or if you like that setup better, because of the ladder diagram, you're making sure you're only pulling out prime numbers. And as I said, I would do 2, 3, and 5. The others, some of them make sense. You'll get to 11. You might see a 7, but I would try to divide those. So let's try a factor tree and a ladder diagram to find prime factorization of 54. So 54, I could do 9 times 6. 3, 3. And factors of 6 are 2 and 3. If I tried prime factorization ladder, I would say, well, 54 is an even number, and it is divisible by 2 because it's even. And if I'm not sure what it is, I could come over here and do 54 divided by 2. 2 times 2 is 4. Bring down a 4. And I get 27. So 27 is not divisible by 2 because it's not even, but it is divisible by 3. I think it'll leave us 9. And 9 is divisible by 3, which is 3. So now we have our same numbers here. Either way, we only have 1, 2, and we have 3 cubed, or 3 to the power of 3. And either way, whether we do our ladder diagram or we do our prime tree factorization, we get the same answer. So now I want your teacher to pause the video here, and then I'm going to go ahead, do these problems, and then when you guys have all had a chance to work on them, she can play it and you can check your answers. So you're going to pause. Did you pause? Hopefully you paused. Okay, so now I'm going to go through this. So use the diagram to lift the factor pair. So 18, you can multiply 1 by 18. You could do 3 times 6. And you could do 9 times 2. So your factors, let's type these, are 1, 2, 3, 6, 9, and 18. 52, so we could do 1 times 52. Since 52 ends in a 2, it is divisible by 2. So we're going to do 52 divided by 2. That goes in 2 times. 2 times 2 is 4. Subtract 1, bring down the 2, and 2 goes into 12 6 times. So you could have 2 times 26. 5 plus 2 is 7. 7 is not divisible by 3, so 52 is not divisible by 3. 52 does not end in 0 or 5, so it's not divisible by 5. I happen to see here that it is going to be divisible by 4, and the reason I know that it's divisible by 4 really is because 26, the factor there, is even. So let's divide by 4. That's 1. bring down the 2. Okay. And so 4 times 13. So our factors here are 1, 2, 4, 13, 26, and 52. Okay, so next problem. Carl needs to build a stage that has an area of 72 square feet. The length of the stage should be longer than the width. What are the possible whole numbers? So we could do 1 times 72. We want to divide by 2 because the width could be 2. And because 72 is even, we know it's divisible by 2. So that is 6. 1. Bring down the 2. That's 36. 72 is divisible by 3 because 7 plus 2 is 9. 9 is divisible by 3, so we could do 72 divided by 3. 3 goes into 7 2 times. 2 times 6. Subtract 1, bring down the 2. Okay, so we got 24. So we got 24 and 3. 72 is also divisible by 4. So 72 divided by 4. 4 goes into 7 one time. 1 times 4 is 4. Bring down the 2. 4 goes into 32 8 times. So we have 18 times 4. 72 is not divisible by 5 because 72 does not have 0 or 5. 72, let's see if it's divisible by 6. Oh, by 6. Hold on a second. Oops. Oh my goodness, if I could press the right thing here. 72. 6 goes into 7 one time. Bring down 1, 2. So 72 is divisible by 6. And I happen to know that's divisible by 8 because 9 times 8 is 72. So we got all of our choices there. Okay. Now we're going to check our factors here. They want us to do a factor tree. So for this one, they did 201 times 2 is 42. Okay, that's a prime factor. Now, 201, so 2 plus 0 plus 1 is 3, meaning that 201 is divisible by 3. So I'm going to do 201 divided by 3. 3 does not go into 2. 3 goes into 26 times because 6 times 3 is 18. 20 minus 18 is 2. Bring down the 1. And 21, 67. Okay. So I'm just looking over my math here because I want to make sure that that's right. 7 times 3 is 21. So I have 3 and I have 67. So let's hear. 67, 6 plus 7 is 13. So it's not divisible by 3. It's not even, so it's not going to be divisible by 2, 4, or 8. Let's just try. It's not going to be divisible. It's not a fate of 7. It's not 8. So I think at this point, we can say that our factors here are 2 times 3. And one of our factors is 67. For 36, I could pull out 2 because it's prime number, but I know that 36 is 6 times 6, and the factors of 6 are 2 and 3, and the factors of 6 are 2 and 3. So to do the final prime factorization, though, I would write 2 to the second power because there's 2 2's, and 3 to the second power. And now they want us to do a ladder diagram. So with a ladder diagram, we only pull out prime numbers, which means I'm going to do 64 divided by 2. I'm getting tired of red here, so I'm going to change colors. Use blue. So 64 divided by 2. 2 goes into 6 3 times. 3 times 2 is 6. There's nothing else to subtract there. Well, we subtract, we get 0. Bring down the 4. 2 goes into 4 2 times. So 2 goes into 64, and we're left with 32. Now, we have to divide 32 by 2. And I think I'll change colors again. I'm feeling like green. I don't know how well you can see this, but 32 divided by 2. 2 goes into 3 one time. 1 times 2 is 2. 3 minus 2 is 1. Bring down the 2. And 2 goes into 12 16 times. Sorry, it goes in 6 times. So I'm left with 16. And now, let's pick a different color. 16 divided by 2 is 8. I just keep changing colors so you're going to follow what I'm doing here. And 8 divided by 2 is 4. And 4 divided by 2. So all we have is 2 here. So we have 1, 2, 3, 4, 5, 6. So 64 can be written as 2 to the 6th power. Now I'm going to come over here and work on 27. Whoa, 27. And I can only pull out prime factors. I'm going to divide by 3. 27 divided by 3 is 9. And 9 divided by 3 is 3. 3 times 3 is 9, times another 3 is 27. So 3 to the 3rd power, or 3 to the power of 3, or 3 cubed is 27. So I hope that helped you out and you feel much more comfortable with prime factorization.